Hello and welcome to this episode of Math with Martinez. In today's video, we are going to use our properties of logarithms in order to evaluate or transform logarithmic expressions. So let's go ahead and begin with our first rule, the product rule. Ladies and gentlemen, the product rule says that if you're taking the log whose base is b, and inside you have things that are multiplying, that is the same thing as taking the log of base b of m and adding to that log base b of n. This version right here is what we call condensed. And the way it's written down below here is what we would call expanded. Condensed means made smaller, made to be just one log expression, a single log expression like you see written here, condensed into a single log, right? And then we have next to that expanded. Expanded is going to be when it is drawn out two things or something made longer. So let's go ahead and look at condensing these couple examples into a single logarithm. Let's begin with log base 3 of 9 plus log base 3 of 5. We are able to condense them because they both are log base 3. That is very good. If they didn't have the same base, they could not be condensed. But because they do, it's a log base 3 of 9 times 5, which is log base 3 of 45. So that would be our final answer here. Log base 3 of 45. All right, let's look at example number 2. At example number 2, we have log of 6 plus log of the expression x minus 3. These are an understood log base of 10, but we do not need to write in that base 10, it is understood. But because they are the same, we can go ahead and condense. This would be to have log of 6 times x minus 3. So that 6 is multiplying with that entire expression in our second log. You would go ahead and write this as 6x minus 18. And we can go ahead and put that all in parentheses so we know that we're taking log of all of that expression. Last but not least, we're looking at the natural log of 4x squared plus the natural log of 3x cubed. Because these are both natural logs, base of e, we can condense them. This is going to give us the natural log of 4x squared times 3x cubed. When we combine when we go ahead and simplify, that means that we're combining the product of 4 and 3. That's going to be the product of 4 and 3 is 12. And then when you go ahead and apply your properties there for your variable, that means you're going to add the exponents. So it would be the natural log of 12x to the 5th power. So there you have it, ladies and gents. There you go. All right. Now let's look at expanding using the product property here. Let's look at expanding using our product property. The product property says that, okay, what are we going to need to take the log of here, two separate logs, so that when you take the value that we have right in this position, they would multiply to give you 72. They're going to have to multiply to give you 72. So what are two numbers that multiply to give you 72? Yeah, one option would be 8 and 9. So that would be one way of expanding this log. I want to bounce all the way over here to 6. Let's look at 6. What would we have? Log base 5 and another log base 5. What two things would we multiply together to give us x squared minus 4? To give us x squared minus 4, what would be the two expressions here that when we multiply them together would give us x squared minus 4? To give us that difference of squares? It would be x plus 2 and x minus 2. And we're going to leave off problem 5 for now and move on down to another property, our quotient property. The quotient property says that if we have log base b of the expression m divided by n, that is the same thing as log base b of m minus log base b of n. So if we are looking to condense, we need to apply this quotient property here. That looks like in this first example, taking the natural log of those two arguments, but we're dividing them. So when you take 96 and divide it by 6, that is going to simplify to what, ladies and gentlemen? Yep, that is 16. And what about, let's jump here to problem 8. What are we going to have there? We would have, we would have log of 8x to the 10th power over 4x squared. And then we need to use our properties to simplify that. That would be log of what expression, y'all? Well, 8 divided by 4 is 2. And then we subtract the powers here when we are dividing. So that would be x to the 8th power. That is much more condensed than it was at the start. And let's look at this last one as well. When we condense this, it would look like the following. We would have log base 7 of the square root of 40 over the square root of 5. Now, what that really means is what is the log base 7 of the square root of 40 divided by 5? 40 divided by 5 is really just the square root of 8. The square root of 8. So quite a bit more simplified than what we started with. And if we wanted to expand these out using our quotient property, I just want to focus here on problem 11. Let's just look at problem 11. Right now we have a quotient, but if we wanted to expand this out, it would be the natural log of 3 minus the natural log of 4. I'm kind of working here in the reverse order. I'm going from this like condensed to the more spread out. So if it is division, then that means we're going to subtract our logs. Last of all, let's look at our power property. The power property says that if you have log base b of m and that n is the power of your argument, then that's really the same thing as taking n times the log base b of that argument. So if we wanted to condense this, here's how that might look. This, ladies and gentlemen, is the same thing as saying log, whose base is the base 10, and our 6 is actually raised to the third power, right? Taking that value that our log is being multiplied, that's actually the power of our argument. And 6 to the third power is 216. That is a bit more condensed than what we started with. Also, take a look at this next one. This would be the same thing as writing log base 4 of 81 to the 1/2 power. And what does 81 to the 1/2 power simplify to, everyone? It really means to take the square root, which is, what is the square root of 81? It is 9. And then last of all, on this last one, we would have the ability to rewrite this as the natural log of 4 to the power of x minus 1. And that is as far as that one can go. All right, and the other way, expanding this out, how would we correctly rewrite example 16 if it was expanded out? What would we do with that x? That is the exponent of our argument 5. Well, we would take that x and go ahead and multiply our log by that amount. Now, what would that look like in example 17? How can we actually rewrite this cube root? How can we rewrite this cube root instead of a cube root, writing it as an exponent? This would be the same thing as saying your argument to the 1/3 power. And so when we rewrite that, we'll just bring that power and multiply our natural log of 2x plus 1 by that amount. And something that would help make example 18 a whole lot easier to work with would be to rewrite this so that we don't have a fraction. And so if we don't want a fraction, what we can do is think of this as, okay, if I want to bring this up, this 64 up into the numerator, that would be the same thing as saying 64 to the -1 power, to the -1 power. Or even better, we could, well, maybe not better, but then last of all, we can go ahead and bring that exponent and multiply it out in front. So there you have it, ladies and gentlemen. Those are our properties of logarithms. We are able to both condense and expand. And in our next lessons, as we are solving equations, you'll see that there are lots of applications as to why you would want to either condense or expand them out. If you had any questions, will you please take a moment to share those now? And until next time, stay fired up.